Hello and welcome to video number 4 in this series of tutorial videos for HDXmodeller, and in this video we're going to look into more detail about how to run jobs. So as mentioned in a previous video, the recommended workflow for HDXmodeller is that data should first be split into different subsections, and then each subsection of data submitted for optimization separately. And this approach, we think, takes advantage of the variable nature of the success of optimization throughout data, throughout a whole data set, and therefore it allows this validation information from the R matrix to be more localized, and therefore it's possible to isolate bad subsections from good subsections. So breaks in experimental data may occur naturally, which means that subsections can be created without having to delete peptides. But in some instances, peptides might need to be deleted in order to create two different subsections of data. However, it's very important to stress that we don't recommend that peptides are deleted haphazardly from data in order to create subsections, and the deletion of peptides should be kept to a minimum. And this is because obviously it's going to have the removal of peptides from data is going to result in that data set being less constrained, and therefore that can have a negative effect on the optimization in general. So HDXmodeller has two inbuilt tools to aid in the preparation of subsections, and the first of which is the occupier tool, which can be found at this URL here. And for this, your experimental RFU file, that's the peptide file here, that should be chosen. You give the project a name and then press upload, and the results will be downloaded automatically onto your browser. So the result is an image of information about your peptides, and the first two here are just general information. So we have this one, which is just the peptide map, and then this top image, this graph here, shows the residue redundancy within your data. But this final one on the bottom here contains information about the occupancy score of your peptides, and the occupancy score can be thought of a measure of the connectivity of the peptides within your data. So as a rule of thumb, you'll notice here, first of all, that some of the bars, well, this one is coloured differently, and as a rule of thumb, we recommend that any peptide that yields a red bar, such as that one, should be deleted completely from your data prior to optimization, because it's highly unlikely that peptide is going to be any use for the optimization. It's just going to lead to erroneous results. And then in general, the occupancy score scales with the sort of importance of peptides for the optimization. And so because of that, if you deem that it's necessary to delete more peptides in your data in order to create subsections, then you should start with those peptides that yield the lowest occupancy score, such as those blocks of peptides that I've just put in the red boxes here. So this is a zoomed in image of the peptide map, and I know from the occupancy score that these 4 central peptides yield very low scores, and so I can delete these in order to create 2 new subsections of data as shown here. And if I look more closely at the data, I can also see that this first subsection of data here actually contains a natural break in the data and can be split into two different subsections as shown 1 and 2. And that's because although these two subsections do overlap with each other here, the overlap actually contains N-terminal peptides, which are coloured in this sort of orange colour. And N-terminal peptides are considered blanks for the optimization, and so these two regions do not actually overlap, and so we can create subsections naturally there. However, the same is not true for the other subsection of data shown here, and that's because this overlapping region is larger. However, if I refer again to the occupancy score for this peptide map, then I know that the occupancy score for these two peptides here is also very low, and so it might be useful to delete these two peptides because they're not adding anything to the optimization. And obviously if we delete these two peptides, then that will enable us to create two more subsections of data. And this is kind of the overall workflow that you need to go through in order to create subsections prior to submission for optimization. Another tool that can aid in the creation of subsections, or another metric that's reported by HDXmodeller is the peptide error. And HDXmodeller will produce an image like this after every optimization which reports the peptide error. Now, any peptides that are coloured in green, as all of these are coloured in green, are below a statistically determined error threshold. But any peptides that yield a red bar are above that threshold, and you might want to consider removing those peptides from the data. However, statistically, even if you have 1 or 2 bars that are red, statistically this is only a problem if the average peptide RMSE, which is shown here at the top, is too high. And this will be too high if your image doesn't receive this green tick. You can just see it here. And if that is the case and you have some peptides that yield red bars, then you will need to delete these data, starting probably just with the highest one, re-optimize it and see if that will address this problem. Obviously, of course, this can be used to aid in the creation of subsections. You could focus on the removal of peptides with high error, for example, and it's very useful, of course, if one peptide has a very low occupancy score and high error, because that makes it very easy to remove that peptide before the data are optimized. So we still recommend that users follow the workflow that we outlined in our communications biology paper, and this will begin with a process of peptide filtering and splitting as shown here. So this is the creation of data subsections using the occupancy tool as a guide. And once subsections of data have been created, then we recommend you begin the optimization with an evaluation step. And an evaluation step is the same as a standard optimization. However, you'll need to change the number of replicates from 50 to 10 for the evaluation stage. Following the evaluation stage, the R matrix should be inspected, and data, only those data that achieves an R matrix score above 0.5 should be submitted for a production run. Ideally, the R matrix should really be above 0.7. And if your data doesn't yield that score, then you need to go back to this peptide stage again, see if you need to delete some peptides, perhaps look at the peptide errors, see if there's a problem there. And if this can be addressed, then you can proceed with a production run. But if a suitable R matrix score cannot be achieved at the evaluation phase, then it's necessary to go back to your original data, see if you can find more peptides in the experimental data, or if not, reacquire the data. And the only thing I want to say about that is that when you get down to a production run, obviously the recommended number of replicates is 50. So hopefully you found that useful. That's more information on submitting jobs and the preparation of data. Thanks for watching, and I'll see you in the next video.